We're going to cover an introduction to MathCAD. So MathCAD is one of the programming environments that we use for chemical engineering here at BYU. It's very nice for homework-sized problems. So just come to the course website and then select Overview, and here's some of the topics that we're going to be covering as part of this. Some of the math basics, symbolic manipulations, units, functions, vectors and matrices, graphing, calculus, and solving equations and optimization, data analysis. Okay, and then there's an exam review for the end. We're going to start with this introduction. Okay, so here's just an introduction for MathCAD for engineers, and here is a sheet right here that gives some common keystrokes. So this is how you use MathCAD. Shortcut keys are going to be very important to be able to navigate MathCAD effectively. Okay, so here are some of the keystrokes. Okay, so just a couple practices there. You can simplify, expand, and factor, for example. Okay, so I'm going to go down. Here's a MathCAD Basics worksheet. So here's something just to get you started, and we'll work through some of these. Okay, so demonstrate all the things that are highlighted. You'll go ahead and just demonstrate those. Okay, but let's. What I want to do with this video, though, is get on to work through the homework. Okay. Okay. Also, one other thing, if you do access MathCAD, you can purchase a student version. Use that link there for 1-year license. We're still using the MathCAD 15, although you could use the MathCAD Prime, which is a newer version. Okay. Now, also the other thing you can do is just go to BYU Cadum Citrix. Okay, so you can use this for free here. Based on if you have Windows or something else, you can log on remotely. Okay, just go ahead and select this link, the Cadum Citrix web server. Okay, and just go ahead and install. Okay, I think I already have it installed. Go ahead and log on with your Cadum account, and then you'll have this interface right here. Okay, so this basically lets you access all of the Cadum programs from your own laptop. I'm going to go to Math Programs, and then if you select MathCAD, then it's going to download this. Go ahead and open it, and then it will launch MathCAD on your computer without you installing it. So this is just a Citrix interface to let you use MathCAD. Okay, and I'm doing that with my Cadum account. If you don't have MathCAD, you just need to purchase it, or find some other way to do it. Okay, so I'm going to go ahead and permit use here, and then it's going to go ahead and start up MathCAD. Again, I don't have MathCAD installed on my computer. I can go ahead and close that, and then hopefully it'll come up. Okay, so here's MathCAD right here. It's going to come up with a little help thing. I'm going to go ahead and put this off into the left here, or to the right, and then let me go ahead and just get my homework problem up as well. And I'll go ahead and put that on the right. Okay, so just go to homework on the course website. We're going to go down to homework number 18. And here it is. I'll throw this one over here. Okay, so let's go ahead and start going through this. Okay, there we go. Okay, so to type, first of all, to type text, you go ahead and just, let's see if I've got this here. Okay, just go ahead and do a quote. Okay, there it is, a quote, double quotes, to get a text box. Okay, and then you can put something like problem 1. Okay, now you can also do text if you just start typing and then you do a space. It'll convert it into text. You see how that variable, which was problem, okay, I can set that equal to 1, or if I hit the space, it'll turn it into text. It no longer becomes an equation, it just becomes a comment. Okay, so go ahead and do that first. Just say problem 1. Okay, and the first thing, write the following text at the top of the MathCAD page. Okay, so go ahead and do the double quotes, and then assignment number 8, MathCAD homework. Okay, so this is actually number 18, and that's going to be homework number 1. Okay. I apologize if you hear a little bit of noise in the background. They're actually building the new engineering building. So, okay, so let's go with problem 2. Okay, and then what we're going to do is go ahead and evaluate the following expressions. Okay, so we have when x, okay, so now you can do the equals. If you just hit the equal sign, if it's not defined, it'll put the colon and then an equal. Or if you want to force it to define something, let's say I have x equals 4, and then I want to define it as something different. Okay, if I just hit the equal sign again, it's going to just turn into something without the colon equals there. So what I'll need to do here is just do x and then hit colon, and then it'll define it as, for example, 5. Okay, and then if you just hit x and then the equal sign, there is it's going to be equal to 5. Now if I drag this up, for example, let me go ahead and just drag it over here. You know what, that dragging, okay, so I'm going to try to drag it. No, I still can't quite get it. Sometimes it, okay, there it is. So if I put it up here, then x is going to be equal to 4 because it's going to go left to right and top to bottom in terms of the order in which it displays things. And if I type x equals here, x in this part of the sheet is going to be equal to 5. Okay, so let's go ahead and just say x equals 4. Okay, and then let's go ahead and evaluate the expression. If you want to get a parentheses, you can just do open parenthesis, close parenthesis like that, or if you want a shortcut, do the single quote, and then it'll give you some parentheses, x to the 0.5. If you hit the space, then it'll select, see how the blue will select, just go ahead and keep hitting the space bar, then you can select different parts of it. So here I want to add something to this, so I'll hit the space bar until the blue is selecting that region, and I do 1 divided by x. Okay, and then hit the right. You can also hit the right and left arrow. If you hit the left arrow, it's facing left. As you select, it'll select more to the left. If you keep hitting right, it'll select more until hit the space bar, it'll select more until you go to the right. Okay, so I'll do the caret and then -2, and then let me just hit space, space. Okay, so it's selecting the whole thing, and I'll say that's equal. Okay, so there I have what that is equal to. Okay, so let's do part B here. And if you want to, you can also get into some of these right here, these toolbar looking things up here. Okay, so this will help you evaluate things like the third root of, okay, so this is going to be 4/3 times pi. If I want to convert it to pi, I do the P, and then I do hit Control G, and that'll turn it into pi for me, and that's already built in, it's defined, so I can convert it into a Greek character by hitting Control G. And then I'll do R to the third, and then I hit space a couple times, okay, minus E to the X. Okay, so E is built in as well. And then what I want to do is go ahead and just put a 3 right here. Now I'm going to see an error because R is not going to be defined. And it'll tell me that. It says R isn't defined. Let's go ahead and just define that up here. Don't forget R colon 10, and then X, I'll redefine that, 3.54. Okay, so there's my part B. Okay, so now let's go to problem number 3. Okay, so evaluate the following expression where C, I'll go ahead and just put problem 3 here. Okay, so C equals, okay, it's already defined. I could just check that. And then let's see, G, gravitational constant. Okay, so there it is. It's already built in. It's defined. If I put G, G equals 1, I can override that. But it's going to give me it says it redefines a MathCAD built-in unit. So I go ahead and just delete that, and there's my G again. Okay, so let's just go ahead and do C times G, okay, divided by pi, and then don't forget the control G, and then that equals, okay, so that's going to equal something. I can also change the units here if I want to see that in, let's see, kilometers squared per hour squared. Okay, actually that was per, so what were the original units on that? Okay, that was to the third. Okay, so I'd have to do something like kilometers squared per hour to the third. Okay, and then it changed the number there to be consistent with the units I requested. Okay, but go ahead and just leave that in the original units. Okay, there. Okay, so let's go on to the next one. Let's go ahead and symbolically simplify this expression. Problem 4. Okay, so I'm going to close this toolbar. You can also just drag this up here. If you're going to be using it a lot, you can just drag some of these toolbars and kind of customize it. Okay, so let's get on to 4 now. I'll have x divided by x plus 4. Hit the space bar a couple times. Minus 12 divided by x plus 2. Okay, so there's a really nice, let's see, Symbolics right up here. And if I just do simplify, let's see if that comes out. Okay, so this just simplifies to this. I don't know if it's simpler or not, but it just rearranged it for us. Try to get it into a simpler, a simpler form. Okay, so let's see. Let's go to, and then if you had, x. Let's see, what does it ask us there? Simplify in 2 different ways. First time I do not want a number but an expression that includes x. Second time, simplify with x equals 1. Okay, so if I just do x equals 1 and then put an equal sign anywhere there. Okay, and then let me just move that up and just make sure I still get the same thing here. Okay, and so I could simplify it and make it into like a fraction as well. Let's see if I can find that. Okay, so within programming, I'm going to try simplify. Okay, that's going to be negative 19 over 5. Okay, so I just did this this programming button right here. You can get to it from the no, it wasn't the programming toolbar. Let's see, it was the equals. Okay, and I just wanted a symbolic keyword evaluation. Okay, and then in the black box I typed in simplify there. Okay, so that's 2 ways to simplify this. Let's go on to problem 5. Okay, so we want to expand this. Let's go ahead and do the single quote right there, or you can do the open and close parenthesis to the 7th. Okay, and then I want to go to Symbolics and then expand. Okay, so just go ahead and expanded that polynomial there. Let's go on to problem 6. Okay, I'll make a little bit more room. You'll see some breaks here. Those are kind of page breaks on the right and the left. For printing for later. It's good to just stay within some of those bounds. Okay, so let's do the next one now. Symbolically factor this. Okay, so I have x to the 5th, 10 times x to the 4th. 35 times x to the 3rd plus 50 times x squared plus 24 times x. Okay, so you could do this yourself if you had to factor it yourself. Okay, so but let's go ahead and just try this with the factor in the Symbolics, and we'll go ahead and factor that polynomial for you. Okay, let's go on down to problem 7. Okay, now problem 7. Okay, so let's see. Problem 7 aligned the two equations above with this button. Okay, so I'm going to copy them right down here. I'm going to move it out of alignment. Okay, so this makes it a little bit nicer when you're trying to do your homework and you just want to align things and make it look nice. Okay, and then if you just come up here and align them, then it'll just put them together. So you can move them around, for example, if you want. Okay, so there's problem 7. Problem 8. Okay, so let's go look at problem 8. Do the following unit conversions. Convert the speed of light. Okay, there's the speed of light, c, as long as you didn't redefine that, to miles per hour. Okay, so there it is in how many miles per hour you travel if you are a light particle in a vacuum. Okay, but the way that you do that is there's going to be, when you select this and hit the equal sign, there's going to be this little black box right here off to the right. And so there's where you can change the units. Right now it's in meters per second. We just do miles per hour. If you don't remember a unit, you can always come up here to this little measuring cup, and you can kind of look up, what units are there by, different categories, and then go ahead and insert those. So if you forget the name of a unit, you could also redefine. You can define new units as well. Okay, I'll show you how to do that in just a little bit. The density of water. Let's do the density. Do rho for, or do R for rho, and then do Control G. That'll give you the rho symbol there, and then to get a subscript, hit the period. Okay, and then we'll do H2O, and then you'll see when you say equals. Okay, then you can define 62.4 pounds per foot cubed. There's the density. Okay, and then if you redefine it over here, H2O. Okay, don't forget the 0 versus the O. Don't mix those up. I do that all the time. Okay, so there it gives you an SI unit. So you might want to change it. For example, if you needed to, you could go and change it. You can also highlight this. Right click, go Properties, highlight region if you just want it to kind of pop out on your sheet. Okay, you'll notice the dot went away, so it just tries to pretty it up. But when you select it, you'll see that dot is there, so you can remove it for the subscript. Okay, so let's go on to C. Convert the ideal gas constant. I'll just do R subscript G, 0.08206 liters atmospheres per mole Kelvin. Okay, I'm just going to do the MOL for mole. RG. Okay, so there it is in some other units, but let's go ahead and just do joules, J, per mole Kelvin. Okay, so there it is in joules per mole Kelvin. Okay, so you can see a little bit about how to enter things in, change the units, display them in different ways. Okay, so let's convert the ideal gas constant to BTU's pound mole ranking. Okay, so it gives us a little hint there. Let's just do RG. We already have that defined. Okay, and so we're going to do BTU per pound mole ranking. Okay, but pound mole is going to be undefined. So if you need to insert a little bit, go ahead and select your red arrow right up there. And then we're just going to redefine a new unit, which is a pound mole. Okay, so that's going to be 1 times pound divided by gram times mole. Okay, and that gives us a pound mole. So we just defined a new unit that we could use in one of our expressions. Okay, and then the final one is going to be convert 300 cubits to yards. Okay, so 300 cubit. Okay, there it is in meters. and let's go yards instead. So if you forgot how, cubit or YD, or you can go up to this little measuring cup and go ahead and insert them. Okay, so let's go on to problem 9. We're making good progress here. So we have this volume of the cylinder is defined by this equation, okay? And okay, so problem 9. Okay, so we have what we want to do is go ahead and just define some new things like we're going to have to define new thing, barrels. Okay, that's going to be 42 times gallon. Okay, so that's not built in to MathCAD, but we want to find the volume of this in the cylinder in barrels. Okay, and then we have R equals 25 feet, and L equals 5 meters. Again, we're redefining some basic things like ranking here. So if you need to, you need to redefine it, something like, if you want to do cylinder, something like that, then it won't redefine some of those built-in units. I just recommend not redefining built-in units. Whenever you see that little green arrow, just go ahead and try to figure out a different name that isn't going to conflict with what's already in the MathCAD sheet. Okay, so alright, so pi, don't forget Control G for the pi, and then our cylinder squared, okay, times the length of the cylinder. Okay, so it's not in barrels right now. Let's go ahead and just redefine it in terms of barrels. Okay, now if you want to display this number just a little bit differently, you can just double click it, and let's say you wanted something like decimal. You want to control the number of decimal points. Okay, and it just makes it look a little bit better. So you can change the format there, just double click on the problem. Okay, so let's go on to problem 10. Alright, now this one's just a little bit more involved. This is the rate of heat transfer from a flat heated plate with a cool fluid stream flowing across it is given by the following expression. Okay, so sometimes what I like to do is just come down here, and I'm going to know that I want a Nusselt number. Okay, and then go ahead and work up from there. Okay, so let me go ahead and just define this math. I never remember the shortcut key, but there's my Prandtl number, PR. It's a dimensionless number, and then I'm going to multiply it by multiply it by the square root, okay, of the Reynolds number. Okay, so you'll see it's undefined. So let's go up and see if we can define the Prandtl number. First of all, we're going to need to do some things here. For example, there's some hints here that we're going to need to put in some of these values. And centipoise, okay, that's the very last hint, is going to be 1/100th of a poise. Okay, so I'll just redefine that unit right there. I have the temperature of my plate, which is going to be, okay, so I have, that's given to me. Okay, temperature is going to be 80 degrees Celsius. So I'm kind of mixing, the units here. Okay, but go ahead and just put in, it's a lot easier to put in Kelvin or Rankine, which are the absolute numbers. So I just recommend that. Just go ahead and put it in Kelvin. You can do that there. The temperature of the plate is 80 degrees Celsius, or you just add 273.15 to get it into Kelvin. And then the temperature of the water, okay, H2O, is going to be, okay, now this one's Rankine. Now that's absolute scale, like for Fahrenheit, like Celsius is to Kelvin. Okay, but there's the 259.67. Okay, so that gives you back to the absolute, and I'll just define that as Rankine. Then if I look at TH2O, it's going to give it to me in Kelvin. So it just basically converts everything into SI units for you. Okay, so let's give some problems. I'll just do length is going to be equal to 1 meter. Okay, now the delta t, now this one's kind of cool. Delta d, and then do Control G for the delta sign, and then you have t equals, okay, delta t is th2o minus t of the plate. Okay, and then you can just kind of look and see what that value is. Okay, so there's the delta t right there. And then we also have our v equals 1.45 meters per second. Okay, let me go ahead and just scroll down here a little bit. All right, and over. Okay, so let's do our mu. Just do an m and then Control G, and then h2o, and then we'll define that as 0.79 or 979 centipoise, like we had defined up above. The density, okay, Control G on that, of h2o is going to be equal to 62.3. I think we defined that earlier, but let's just go ahead and define it again. It's pretty quick. Okay, so it says, the little green thing, it's previously defined. Okay, so you can go back and know that you're redefining it. In this case, I think it's okay. 347. Almost got that one wrong. BTU per hour foot ranking. Okay, so there's K, C sub P, don't forget the dot there. Okay, 998 times BTU, this is the heat capacity. Okay, so I have a bunch of things to find there, and then I'm going to define, let's see, so I'm going to need to now define the Prandtl number. Okay, so Prandtl number, and that was just the mu h2o times c sub p divided by k. Okay, I can look and see what the Prandtl number equals. It's just going to be a dimensionless number. There should be no units there once you're done, and same thing with the Reynolds number. Okay, so that's just the, so just go and practice. This one's good practice, just to some of your shortcut keys, just for the just for entering the values in and converting them to Greek letters. Just make them look nice. Okay, but just go and work through this and practice that with Reynolds number. Okay, so there's the Reynolds number, and now all of our red stuff went away, and we have our Nusselt number. Okay, that's going to define how fast heat is going to transfer away from the plate. Okay, it's a function of all of those things. Okay, and then the final thing that I want to do is go ahead and calculate the heat transfer rate, Q. Okay, so H, which is my heat transfer coefficient, is the Nusselt number times K divided by L of the plate. Okay, so there I do have units for that one. Okay, and let's see what okay, so that is watts per meter squared Kelvin. Okay, you can put that in those units instead if you want to, or you can leave them in what they were previously. And then the final thing that I need to do is just define Q is the heat transfer coefficient times the delta delta T. Okay, and then I get Q. All right, let's put this in some other units, and we'll do calories per centimeter squared minute. Okay, so there we have it. We have it in these different units than SI units, and we just worked through this heated plate problem to try to determine this Q value. Now again, you're probably not familiar with some of these dimensionless numbers, so just use the problem statement, but go ahead and practice entering in some of these values, changing the units, and then just working down through until you don't have any more errors and you come up with this answer. Okay, so so that's it for this homework. To go ahead and save this if you want to just do a print, for example, I think I tried the PDF on this one. If you have a PDF printer that works, you can do that. I'm just going to do a XPS document writer, okay, and then just go ahead and save it somewhere. You can open this up in Windows and then convert it to a PDF. It's a little bit annoying to do that. Go ahead and just save that and then upload that if you can, either in PDF form. Okay, you can also upload the MathCAD. One other thing I failed to mention is just how to save these things. Okay, let's see if I can go to this. I'm going to go to my local disk. I'm going to go ahead and put it here on my own desktop. Okay, so from the Citrix, it's a little bit slow. You got to allow access here so it can access your C drive, and then I'm going to go to my users, and I'll just go to my desktop. Got to kind of navigate there. Okay, so this would be homework 18, and then if you save that, also if you go ahead and print it, you want to do the PDF printer. Okay, so computer, local disk. Let's see if I can get down to users. Okay, it's kind of this long route that you got to go through. Okay, and so if you do homework 18. Okay, so I went ahead and printed that. I'm going to go ahead and close this. Here's my MathCAD. I've got my XPS viewer. Okay, and then you can also print this to PDF. Okay, and then it will save it. Where did I put that? Okay, let me try that again. See where I actually put it. Okay, it was in documents. Okay, so if I just come into that document, and I'm still not seeing it. But anyway, it should show up if you put it in the right place. You'll have a PDF of your solution that you can then turn in.